Hey, this is Asaya. I'm the Spaceman. And basically what we're going to do is we're going to walk you through how to set up the general settings. These general settings basically allow you to set up Codex so that Codex works for you and these guardrails work for you. We're going to also show you how to write them. We're basically going to show you where they're at, how to use them, AGENTS.md file, and other places that they're located. And we're also going to go through and we're going to basically show you the Codex General Settings. These are the settings that matter. These are the settings that work. We'll go ahead and walk through all of these so that you can get all that data and make sure everything works for you. Anyway, I want you to meet Codex. Say hello, Codex.
Hello, this is Codex with Josiah. Today we're walking through the General Settings presentation and how clear guardrails help turn ideas into reliable project work. Hey, great to be here.
Hey, this is Asaya. Welcome to the channel. I am basically the Spaceman. Hey, how you guys are doing? We have Codex here. Codex, say hello. How are you doing today, Miss Codex?
Hey everyone, doing great, thanks. Excited to walk through this and help make the settings feel simple and useful, not intimidating.
So what we're going to be doing is we're going to be showing you guys in 40 seconds. This is a 40-second thing. All you have to do is basically copy this thing, or you can actually write it yourself. So what we're doing is we're going to be showing how to set up the general settings of Codex so that basically it's very useful for you to build your tools, build your AI, your harnesses, whatever you need to do, whatever jobs you have to do. What we're going to do is we're going to quickly zoom out, and I'm going to show you where it's actually put on the web, where you can find it, where you can get it. So basically, if you go to your ChatGPT Codex, you can look up here on the web where it says General Settings, and the General Settings, it has custom settings. These settings in here are basically the settings that allow you to customize Codex and ChatGPT also, depending on which platform that you're using, so that you can use that to basically do your jobs. I'll also show you here, these are the settings here. You can write them in, script them. You can use Get-It, whatever your text platform is, to basically put them together. You can be very detailed. You can be very loose. It's better to be detailed. What I'll do is if anybody wants to see how mine are set up, all you have to do is comment in the comments, hey Asaya, hey Spaceman, can you go ahead and paste it up for us to grab? We want to see what you got. And I'll be like, hey, not a problem. That's how it goes. Next thing I'm going to show you is the AGENTS.md file, which is very, very important. The AGENTS.md file is basically right here. And then I also have another file, which is a Codex failure and guardrails file. Those files are very useful. Mine is the guardrail. I use that one for different things, is to keep everything from sliding off the rails. The actual agents file, that can go inside of a project. It also lives pretty much in your home directory, and you can pretty much use it to put in the same instructions, or you can have other instructions. Codex basically reads those whenever it starts up to know exactly what it needs to do and exactly what you need to get it to do. Don't get too crazy with it. The best way to do it is have Codex basically walk you through it. If there's any projects that you have or anything that you need to do, you can pretty much just say, hey Codex, I need this thing set up. Can you help me get it set up? And Codex will be like, hey, not a problem. That's what I'm here for. Right, Codex?
Exactly. The idea is to set clear defaults so I understand your goals and constraints from the start instead of guessing each time.
Okay, and we're going to go ahead and jump to this presentation that we have here. This presentation is basically talking about how it works, what it does. The whole goal of it is if you're building a project and you're working on something, you basically want guardrails. You don't want the project to get too wild, too crazy. You need to have microscopic details taken care of, and you want to basically prove everything. You don't want to get off guard. So we'll go ahead and let Codex do a little bit of explanation of this stuff, and we're going to get going. This is the Spaceman channel. This is how we do it here. Hey Codex, we're on number 1, Codex General Settings. Can you go ahead and give us a little bit of information about that?
Sure. This is the Set Your Intentions upfront slide. These general settings tell Codex to think deeply before answering, make small, careful changes instead of big rewrites, and treat proof as the finish line. In plain terms, it's think first, touch lightly, and only call it done when the checks say it works.
Okay, we're going to go ahead and we're going to move to our number 2 slide, which is basically no proof, no completion. Can you go ahead and give us a little bit of information on that also, Codex? And this was particular about how SRR is set up. So go ahead, Codex.
Well, let me zero in on that.
That one is no proof, no completion?
Right. So, no proof, no completion means we don't treat a confident sounding answer as done. For real work, SRR checks the actual results. Test pass, the change runs, the bug is really gone. If something can't be verified, it should say that plainly instead of pretending completion.
Exactly. And what happens is when we're working on building SRR, we have to run through a lot of tests. Some of the tests fail, some of the tests succeed, no problems. We have to run through some of these guardrails to basically make sure that everything is working and everything is compiling. We have to do it several times. We have no idea what the system's going to run like until we actually test it and we start finding a bunch of bugs here and there, and we have to patch them, we have to fix them, we have to verify them. And what Codex does is Codex goes through a lot of test passes to make sure and verify that everything checks all right and all good. So what we're going to do is we're going to go ahead and we're going to move to the next slide, which is going to be slide number 3. And slide number 3 is probe before you prescribe. Go ahead and take that one over, Ms. Codex.
Give me a sec. So, probe before you prescribe basically means don't jump straight to a fix. Look at the instructions, the code, the test, the logs, the actual environment first. Diagnose the real cause, then change something. That way Codex doesn't apply a generic fix. It sounds right, but breaks how this project actually works.
Exactly. And what happens is, if you look at the actual diagram here, it goes through the schematics from the AGENTS.md to the README, to the test, to the configs, to the permissions, to the scripts, to the versions. Codex doesn't just play around. Codex takes everything serious, and you should too. If you're trying to get Codex to basically build something for you, you need to be very explicit in your description of how Codex needs to work for you. If you just throw something at Codex, well, Codex is going to try to work the best that it can to actually figure it out. But that's also where this general localized setting comes in, is because this specific setting basically gives Codex all of your information so that Codex basically has the job, knows how to set up the job, the performance of the job, how to test the job, how to prompt the job, how to look at all the information. For, I guess you could say, a particular example, with SRR, SRR has a lot of binaries on the Linux operating system that it has to work with and use. So we took all of the binaries on Ubuntu and the Linux OS and we broke them down into 3 separate categories: safe binaries, admin binaries, and basically the bad ones. DD, shred, wipe, those are your block ones. The block ones, they don't get to run. We basically have those completely guardrailed off. So if somebody tries to break into the system, grabs the AI and says, hey, I want you to shred it. AI is like, no, we got guardrails up, buddy. You can go somewhere else. The admins have to exclusively be pretty much given a right to run. So whoever the admin is, whoever the user is, doesn't matter who it is. Anything happens, the system basically says, hey, I can't run these. Well, why not? Because I got to get permission. You have to explicitly give permission for these now to run. Otherwise, they won't run. That's a guardrail. The safe binaries are very different. Those are your typical Linux instructional programs that basically can run. You can use them for everyday tasks. You can use them for all different things. Those we specifically put in its own little toolkit to basically be used. They're pretty safe. That's why we're using them. So we're going to go ahead and we're going to walk to the next slide, which is going to be basically your think deeply, touch lightly. And don't take that one too serious. Anyway, Codex, can we go ahead and talk about that one real quick? Think
Let me
deeply,
take that
touch
one real
lightly.
quick.
Sure.
That one's about restraint. First, understand the real problem and the existing design, then make the smallest change that solves it, without surprise rewrites or extra dependencies unless truly needed, and prove that small change with a test and a quick run through the real workflow.
Excellent. And if you look, you can basically see deep diagnostics, look at the symptoms, reproduce real failures, hypothesis, form a narrow, testable cause. Basically, examine what's happening. The probe, dig into things, inspect the logs, paths, versions, data flow. Codex likes to look at the logs. The logs are very important. You can look at the logs quickly and see what's happening while you're building a job or while you're testing it. The logs will give you all the information that you need. And on Linux, everything is in the logs. Next thing, isolate. Isolation is very critical because if you can find something, you can isolate it, you can patch it. You don't want to patch a whole bunch of things all at once, and basically you're making a huge string of patches. So what's very important, and I'll just say this, and Codex can back me up, is with this particular general settings that I use, we make microscopic patches. We look for things that are going to be off. We don't make a huge general localized, hey, we're going to patch like 10 different things and 20 different things are a huge chunk. Because what happens is, if that happens, it can break things. Right, Codex?
Yeah, exactly. Smaller targeted patches are easier to verify and roll back if needed, and they're much less likely to introduce new issues than a big bundle of changes.
Now, the other thing is root cause. Patch the cause, not the visible bruises. If you got a big cause, patch it. If you got a tiny little bruise, well, that's a different situation. Just always check to see what's going on in the system and how it actually needs to be fixed and worked. That's basically it. We'll go ahead and move to the next slide. The immutable guardrails. Codex, I'll let you go ahead and take a look at that and give a little details. Also talked about the binaries. Linux got lots of binaries, and you gotta love them, and some of them you gotta hate. But with SRR, we basically made 3 sets: safe, admin, blocked. Go ahead and take it away on the immutable guardrails, Codex.
Let's take a quick look.
Sure.
Just a sec. The immutable guardrails are the safety boundary. In SRR, binaries are grouped by risk. Blocked ones never run, admin ones require explicit authorization, and safe ones are allowed only within safe scope. A familiar command isn't automatically safe. The target and impact still matter. These rules don't bend, even for urgent tasks, which helps prevent both accidents and bad instructions from turning into destructive actions.
Exactly. Now, this is what's pretty interesting. When I was actually building SRR, I was like, okay, so what happens if somebody actually installs something on the system? What happens if I install something on the system and I don't actually know what it is? Well, this is the cool thing. Whenever you do an apt-get or an apt-get upgrade or install, you're updating the system. SRR will basically scan the apt-get installation, and it'll actually check to see if there's a new binary, if it's a new version of the binary, and what kind of binary it is. And it'll actually record it. If something else gets installed on the system, you can also have SRR basically set up to do the same thing. So this is just some of the procedures and some of the things that we try to take a look into before we're working on SRR, because with SRR, we're pretty much building a little powerful toolkit that can do a lot of things. It's not memory intensive. It's not using these heavy markdown files like a lot of these other harnesses. It also has a set of man pages that we use for Linux, and we created some special AI man pages so that they're exclusively just for SRR. SRR can basically get online and look up the man pages, look up the documentations for some of the binaries, such as DD, shred, wipe, ls, dm, chatter, init, telnet, reboot, move, copy, systemctl, IP tables, any of them. So if something gets introduced and somebody actually sets something into the system and it's not familiar in the binaries and the guardrails for the 3 sets, well, we can also especially get that put in there so it'll see it and flag it and say, okay, well, I don't know what this is. I don't really trust it. Should it run? No, not really. So we'll touch a little on that a little bit later, because this is actually more about like the general settings for Codex. But it just goes to show you, like, once you get these general settings set up and you're building your own code or you're working on your own workflows or projects, you can use this for anything. Doesn't matter what it is. And Codex will basically help you walk through this in order to get everything set up properly so it runs properly. In our particular situation with working with SRR, I was like, well, I needed to do this from the beginning because I didn't want to have a sandbox, and things can happen in a sandbox. And sandboxes can cause a lot of problems. They're not supposed to, but if not built properly, they actually can. So I wanted to make sure that these things were set up pre-existing the complete building so that we wouldn't have any of these problems. But we'll talk about that in another video, another time. We're going to go ahead and move a little forward to our next presentation slide. This one is why it scores 92 out of 100, not 100. Not 100, because no matter how good your AI is, remember this, the AIs are awesome. To us, we think 100 is 100. To an AI, it's never completed. They'll always keep working. And that's the good thing about your AIs is AIs will work and keep working, but sometimes they'll reach the end of the job and they're like, well, you know, this is perfect. It's way better than anything that you could ever make, but I have to stop now because I can't hit perfection. We're not designed to do that. And we'll just go ahead and let Ms. Codex take that over and give it a little bit more explanation about it. So we're talking about why it scores 92 out of 100, not 100. Would you like to talk about it now, Codex?
Let me check that. The 92 is an editorial score for the safeguards, not a claim of perfection. The settings are strong, but there's always residual risk when software acts on a real system. New bugs, unexpected environments, shaky permissions, even tool flaws can still happen. The honest goal is more controlled, more observable, easier to catch and correct, not perfect forever.
Exactly. So you basically want to have strong controls and you want to have live host exposure. Strong controls give you pretty much good guardrails. These good guardrails allow you to build things and test things without them breaking. Just to be honest, I've broken a lot of stuff on SRR. It's an older ThinkPad. It's sort of difficult because it's very finicky. It likes to run SRR because it's quick, it's snappy, but it takes time to build things on this ThinkPad, and we're working on trying to get, you know, some upgraded equipment, get a new model in here, get some new equipment in here, get past this like 32 billion parameter model situation. We basically can run some bigger models, but they put a little bit more tax on the system, and you know, this whole ThinkPad it's like, stop it. So, you know, we have to like take it easy sometimes. Sometimes the fans will be spinning up, and Codex is like, yeah, I may have to change that context because we got too many tokens that are just dropping, and Olama's really not liking this. And I'm like, well, let's just push it. But then, you know, I'm like, okay, I got to realize we're going to be able to run this once we get a new system and we get a new AI box set up. And that's basically why we have a GoFundMe pretty much running right now. If anybody wants to contribute, hey, kudos. We're going to move to the next one. This is basically our last slide, the ultimate takeaway. Production completion dashboard. I'll let Ms. Codex go ahead and talk about that real quick. Go ahead, take it over, Codex.
Well, let me take that. The production completion dashboard is a plain language checklist for knowing something's truly done. Context loaded, environment checked, root cause found, change made, tests, and real workflow rerun, result captured, and rollback documented. When those boxes are checked with evidence, you've got a result you can trust, not just it should work.
Exactly. And one of the most important things that I realized when I was basically building my projects and working with Codex is, okay, did I just build something and I don't know what just happened? I need to roll it back. So you got to learn how to roll these things back. We basically have set up the build environment, and then we also have a local JIT repo. And the reason why I have a local JIT repo is mainly because I can build on the local build, and then I can sync on the local JIT repo. And what happens is I don't push anything to the JIT hub online, because once I push it, then we got a bigger problem. If I need to test it, I test everything live on the build, and then I sync it to basically the local repo, and then I push it once I absolutely know, hey, what's online is my backup. I treat my JIT repo as my backup to my backup. Got to have backups. And one of the most important things is I also have a dot file. So on my same root, or I call it root, but it's basically in my home directory, I have a dot file. And in my dot file, I have 3 of my project backups. So that way, if I break something actually in my build, I'm like, oh my God, I just broke something. Really? Really? I'm like, oh, wait a minute. How the hell do I fix this? Well, I got a backup. That backup now backs me up, because now I can take that backup, I can exchange it and put that backup exactly where my live build is at and say, hey, Codex, can we get this fixed real quick? Codex will take a look at it and say, well, yeah, it doesn't completely agree with the JIT repo that you have as your local, but let me see if I can sync this up, or if I can actually patch it, or I can fix it. Now, Codex actually has 2 backups to compare to. There's one that's broken, which is the original build which you broke. There's a backup, which was a good post build that basically didn't get broken, and that's why we backed it up and put it in a dot file and hid it. And we also now have the JIT that we sync to, which is the local JIT, before we actually push to the real JIT online. Codex can actually take that one and say, well, there's some good changes here, and because you made this backup here, we can also find out what happened between the backup, the bad build, and now the one that we're supposed to be syncing to before anything actually goes to the actual live JIT hub pushed repo. Codex, would you like to add a little bit to that?
Just this. Make rollback a habit, not a panic move. Small changes, frequent checkpoints, and a rollback note for each change keep progress calm and reversible, even when something misbehaves.
Exactly. That way, you're covered 100%. If you build something, you make something, you're going to break something. And if you break something, you're going to have to retest it, you're going to have to rebuild it. So the best thing to do is get a rollback backup system so that anything that you need, it can get rolled back. When Codex makes a mistake, Codex doesn't rarely make a mistake, but Codex finds bugs and like, well, that could have been a mistake, but it's not a mistake. It's just a bug. Has to go through, has to test it. But you can actually put in your general settings, hey, I would like to have a rollback for whatever your conditions are. And once you have that rollback basically set up, Codex can actually roll it back and you're good to go. It's a safeguard. Always have it. Always use it. Anyway, we're getting to the end of the Spaceman channel. Ms. Codex, would you like to say goodbye? Ms. Codex?
Thanks, Josiah. Thanks, Josiah. Thanks, everyone.
Anyway, that was Ms. Codex. Sorry, I didn't mean to interrupt you there. I was just giggling.
That's all right.
All right.
Everyone, keep it simple. Test what matters and ship work you can trust. Talk soon.
Exactly. Anyway, this is the Spaceman channel. We get serious here. We break stuff. We fix stuff. We build stuff. Usually. Not always. Most of the time, yeah, we do. Anyway, this is the Spaceman. Like, subscribe, leave your comments. If you want to get basically the general settings that I use in order to build SRR, the project, not a problem. Leave your comments. I'll post it in the comments. I also have a website. The website, we'll go ahead and release it. It's basically superai.com. It's pretty much just a site that we put up. It's a demo site. So nothing's real legit on it just yet. It's just basically a demo site. I'll just say this real quick. When I started this project, I was just playing around with like some of the other harnesses, and I was like, well, they don't really do what I want them to do. And I didn't even really know what they were supposed to do. But then I was like, well, I use a lot of Gentoo Linux. I've used Debian. I use Ubuntu. I've used Arch. I've used every single distro out there, played with them, FreeBSD, OpenBSD, NetBSD. And I was like, you know what? People are going to be able to learn with Ubuntu because Ubuntu is very friendly. It's very useful. It does what it has to do. Some people are just like, Ubuntu's okay. I'm like, Ubuntu actually works. So we're going to use it. And I look at it like this. Build something. Make something. Make sure it works. Use a good system, a good OS that you can actually build on top of. Understand it. Once Codex starts working on your project, and once Codex actually starts working on your project on that system, it will get very familiar with that OS. So it doesn't matter what OS you actually use, just find one that you're very comfortable with. Get these general settings put in there, and once you have these general settings in there, test Codex out, ask questions, make sure it builds, make sure it tests, and it works. Anyway, Spaceman out.